to forgive myself. 'Cause I ain't tryna be your ex, so don't call me if you wait. Tryna vibe on my way, I'm on top of my game. I'm on my way, I'm on my way down. So don't call me if you wait. Tryna vibe on my way, I'm on top of my game. Hanging in the backseat, hanging in the backseat. I'm on my way, I'm on my way, I'm on my way there. And even when we try to throw this all behind, I find myself inside of your arms again. And what if I'm insane and taking me for granted? I would never come to forgive myself. 'Cause I ain't tryna be your ex, so don't call me if you wait. Tryna vibe on my way, I'm on top of my game. I'm on my way, I'm on my way down. So don't call me if you wait. Tryna vibe on my way, on top of my game. On my way, on my way down.
Hello, beautiful people. How are we all doing today? Welcome to first learning week of Python and your first PPL of the Python track. I hope you're excited. Just last week, we were onboarding you guys, and this week, learning has already started. I hope you are very excited for the journey, and I hope that you are well equipped for the journey that is on the way. Let's just have a quick icebreaker. Just let us know where you're joining from. Let us know in the chat. Yeah, I'm joining from Lagos, Nigeria, and it's quite sunny today. The weather is really sunny. So let's know in the chat where you're joining from. Are you joining from Ghana? Are you joining from Rwanda? Are you joining from Kenya? Okay, Pascal says joining from Kigali. Okay, Kenya, Ibadan, Nigeria. Okay. Welcome everybody. Kigali, Rwanda. Okay, welcome. Diana says she's joining from Kenya. Okay. ALX Ob in Kenya. Okay, that's good. Mutero says joining from Kenya. Okay, welcome everybody. Welcome to your first PPL session of the Python track. I hope you're feeling great. Okay, my name is Alima, and your host for today, and your technical mentor for today is in person of Lekun, who is going to take you through your first PPL session. You guys should join me welcoming Lekun as he takes the floor. You guys should drop your emojis, your emojis. Are you just let's usher Lekun in. All right. Hi Lekun, your floor is yours.
Hello. Hi, Lima. Thanks for the introduction. Hi, everyone. I see about 26 people actually joined us, so hoping that number actually gets a little bit more in the hours ahead. So thank you so much. Let me reshare my screen before we get started. There are certain things that we need to take care of first. All right, awesome. Okay, so just as a rule of engagement, before we get started, if you've got any questions, post them on the Q&A section. If you would like it to be answered immediately, maybe you can use the chat area as well. I'll be opening that on my second monitor and I'll be seeing that. So if you have any questions, you can put them there. Feel free to use the chat liberally but be respectful enough. Let me just check. Okay, awesome. And yeah, listen, learn, and engage. So today's session that I prepared for you guys is going to be about Python data structures. I already have a document, like a notebook that I will be walking you through, but it's not just going to be me walking you through everything. I hope that you're going to be opening up a notebook, an empty notebook on your side as well. and following along. So just, I want to make it engaging. I'm going to be asking you some questions in the middle as well. So just, feel free to jump in and use the chat. I would love it to hear from you guys also. So if that makes you comfortable, then, I can give you the chance and open the floor for you guys as well. All right, so that's me. Before we get started, though, there are three resources that we want to share, particular to the current projects that have been released for you. Let's go back. So the first thing is the link to the assessment guide on data structures, the coding challenge. I think let me just open it up here. We'll be sharing these links along with the recording of this session later on, but also I'll be pasting it here on the chat so that you have access to it as well. Just put this one here. I hope you can see it. Thumbs up. Can you open it up? Maybe just check on your side if you have access to it. You should have access. It says external here. I think you should have access. This is the guide. So this guide provides all the information that you need to correctly submit section 412 data structures coding challenge. In this PDF, you have a link to the notebook that you can download yourself and use. You can use Jupyter notebooks to open it up in case you cannot access it from Athena, that is. Okay, so you can just click it here and download it. And read through all the coding challenge guide carefully and follow all the instructions. Yeah, so just follow everything that's pointed out here. So yeah, that's the first PDF guide that we wanted to share. The second one is tips. So this is linked to the data structures coding challenge tips. Right, so just take a note of this one as well. You can read it. I don't want to waste a lot of time. I'm going to paste it here, and later on it will be shared also with you alongside the recording of this session. This is just a tip on how to go through the challenge, okay? And the third one will be if you prefer a video version of it, then you can have it. And so just copy this one as well. And paste it here. So in the order that you see it here, I've pasted it on the chat, so you should have access to everything. All right. The other one is the AutoGrader code challenge submission tips. So for all of you who are like me, Mac users, if you zip a Jupyter Notebook, for example, code challenge dot this Jupyter Notebook extension, it could be zipped as .zip. So ensure that you edit this one. So code challenge dot ipynb.zip to code challenge.zip, else the auto grader may give an error and not be able to grade your coding challenge submission. Just take note of this, okay? It's very important. Make sure for Mac users, make sure that it is renamed, or you have to edit the name to code challenge.zip. That's the first one. And the next one is when you upload your notebook to the AutoGrader and get a good score, but you are not comfortable with the score, you can save a copy of the notebook before making any adjustments and resubmitting. Else, if you score, let's say about like 80%, 86% and work on the notebook, and say you score about like 34, you can now get back to 86 until you cannot get back to 86 until you revert back to the initial notebook that gave you 86%. Okay, so everything has to be intact. You have to revert back and come back again, okay? And if you did not save a copy, then you'll be stuck with a score of 34%. If you need more details on that, I guess you can ask Segun. He'll be available on Azure Base, and also the other mentors should be able to help you out on this. Now that we've got all those heads up out of the way, let's get on the show. Okay, this is just a Q&A, sorry. All right. Awesome. Just zoom in here. Actually, it's okay. Can you see everything on my screen? Is it visible for you guys? Thumbs up, thumbs down. Should I increase the size maybe? You guys okay? Okay, yes. Okay, great. Well, in that case, let's get started. Peace. Okay, so Python's built-in data structures is today's session. So you already see them here, right here, like the list, the tuple, the set, and the dict. These are the ones that we're going to be looking at. And so we'll be going through this by using a live data that we are going to be pulling in from the internet. So we'll see about that later on. We are going to be linking SQL also here, so that I want you guys to appreciate like how SQL data can actually be pulled in into Python and be put into either one of these data structures in the Python code itself in your memory. Somebody's saying they cannot see my screen, and just increase the size ever so slightly. That should be okay, I think. All right, okay. If you still cannot see it, then maybe it could be on your side. The resolution may not be good, I guess, or your network may not be okay. So maybe you might have to see the recording later on to see those that you have missed. All right, okay. So, all right, awesome, that's great. All right, so let's get started. So before I get started though, I want to ask you guys, like, so far you must have used Python. You must have gone through YouTube videos on how to use Python, write programs with Python, all that stuff. So I just wanted you guys to put on the chat, what kind of data structure have you used so far? Because I want to know like how experienced you guys are before going into in depth into everything. But don't worry, I'll actually touch upon everything. I just want to know like where you guys are. So on Python data structures, I just want you to put on the chat, I've already touched blank. I've already touched lists, tuples, dicts, anything you want. So Albert is saying lists and tuples. That's awesome. That's great. Anybody else? If you haven't yet, you can also say I haven't yet touched anything. Anybody? Strings, integers, floats. Suleiman say that. Nothing yet. I haven't yet. Okay. All right. All right. It's interesting. So Lemon said like strings, ints, and floats, those are actually not data structures per se. Those are data types. Those are primitive ones, which are the fundamental or the basic building blocks of data structures. But it's great to know that you know these things. It's always great to first, create a summary of what you already know before learning something else, because, our mind is kind of like a sliding window. Sometimes you might forget things that you've learned before. So just like large language models do it, you need to keep some kind of a summary so that you don't forget stuff that you learned before. Okay, dictionaries, that's nice. Dictionaries are very great. Lists and dictionaries, tuples, that's great, Caroline. All right, so, well, I now see that some of you guys have already used some of these data structures. It's okay if you haven't yet. There are some of you who haven't. Now, I would like to ask you guys about like, or maybe like give you a direction on how to utilize these things. Don't worry about it. This is just for those who already know it. So why do these four containers are required in Python, right? So for example, if you have a question about like some data that you want to store, and yet the order is important for you. If it's important for you, ordering means basically like the positions at which all of your data are going to be put in your data structure, right? So when you talk about data structures, I briefly mentioned earlier, somebody said, actually Suleiman said, he is familiar with the primitive data types, right? So the idea of a structure is creating a compound type of data that has all of these structures together, set in a specific way. And each data structure that you create have its own way of accessing elements, its own way of ordering stuff, um, its own policy of accessing or manipulating data inside. So all of that stuff is set up for you so that you can use it, right? So the idea is you have a structure first, and then you subscribe to those structures depending upon your use case. That's the idea of the separation of the data structures. I mean, you could simply create an object, which you will learn later when you go into the class Python classes section of this track. You can just create normal unstructured data using objects. But that's just user created types, right? They're not really universal and nobody knows about them. But these are actually like vetted data structures that are transferable between programming languages. It's not only for Python. I mean, here we have lists, but if you go into, let's say, other programming languages like C or C++, you find them as being dynamic arrays. They're called arrays. In JavaScript, they're called arrays again. There's different naming in different programming language. When you talk about dictionaries, for example, if you go into like let's say PHP, they're called hash tables. They have different names, but the underlying structure in the way you retrieve data, that the way you add data into the structure itself is the same, right? Across all programming languages. Okay, so if ordering or is order part of the data? Is ordering important in your data? If that's the case, then tuples and lists are your best containers to use. Don't worry about like why this is, because we're going to learn about them later on, right? Um, should your data be changeable or mutable? Do you want to change elements inside? Well, in that case, you might want to use either dicts or sets or lists, but not tuples, right? Are duplicates allowed? Do you want to allow duplicate data in your data structure? Well, in that case, you might want to use only like lists or tuples. Dicts and sets, they're not great for this, right? So you wouldn't use them. And are items looked up by position or by name? Depending upon those, you might want to choose lists if you just want positions. Positioning means just like you have a bunch of boxes side by side, and each box has its own numeric value, starting from 0 all the way up to infinity, right? So that's what it means by positioning. Um, looking up with positioning, right? So what if you want to look up with a name, right? A specific name, instead of saying, give me the 31st element in the data structure. Instead, you want to say, give me the element with the key name, right? The name is the key itself, right? So yeah, exactly. If you want unique data, use sets, exactly. Well, in that case, if you want to use names to access elements, then you might want to subscribe to dictionaries. So that's the whole idea. So this should give you like why you would want to use different types instead of creating a generic one that you want using classes or objects later on. All right, so let me ask you guys. So let's say you want to store learners that come into a class, but in the order that they're coming into the class. So which one would you prefer? Lists, tuples, sets, or dictionaries? Put it on the chat. So the scenario here is the order of learners is important, but also you want to store each learner in your data structure. but the order is important. So what would you use in such cases? Couples, lists. Yeah, exactly. Tuples you can use, however, maybe you want it to be, editable, right? So there's a problem with, it's not actually a problem, it's kind of a policy that if you're using a tuple, then you will not be it's not mutable, right? So the best answer, it's not always the correct answer, but the best answer is using lists here. All right, okay, how about the second scenario where you want to store a GPS coordinate, latitudes and longitudes? How about in that case? What do you want to use here? Okay, so people are saying dictionaries, tuples, dictionaries. Oh, it's interesting. Okay, so the best fit though for this one, the best fit is actually a tuple. We will get to know about that later on. But just to give you a quick sneak peek, latitudes and longitudes don't change, right? So because of that, it's much more better to use just a tuple because it enforces that throughout your code. So if at some point you make a mistake and try to edit this value without knowing that it's actually a tuple, then you wouldn't be able to like edit any of these, right? So because of that, it really holds your hand in writing your code. And at some point, if you forget, then it's going to raise an error. If you use dictionaries, then you can change the values in there. But GPS coordinates of objects in the world, for example, or maybe like places, for example, a city center, it will never change, right? Forever. So you wouldn't want to change those. So the best fit data structure to use for this case is a tuple. We will get to know about like more about tuples also when we're using when we're calling data from a database management system, and you will appreciate why do we use lists? Why do we use tuples at that moment? Okay. Okay. The third scenario is the set of distinct earthquake types in, let's say, today's data. So there's this website where you can go to download today's earthquake data about a specific place in the world. You can actually get that data from online. It's always live. It's free to use by anybody. I'll show you guys how we can use that later on also. But like if you want to store earthquake data, what would you use in such case? Let's say that the Richter scale is what you want to store in your, yeah, exactly, right? You would use sets. Why would you say? Then, well, for one thing, ordering will not matter for you if you're using sets. We'll see about that later on. You might find some duplicates in earthquake data, right? There could be like a faulty, sensor that's sending duplicate earthquake data to an endpoint, and that gets stored in a database, and that database is being queried by Python, let's say, and you want only those that are not duplicates, right? In such cases, it's the best fit to use is a set. And by the way, also, since the list is going to be so much big, if you're using a set, it's very fast to retrieve data also from there instead of lists, for example, right? Great. You guys are good at this, actually. Okay, so how about a learner's profile? A learner's profile, name, email, cohort, etc., etc. What would you think is the best fit for this? Okay, quick fingers. Lucius says dict. That's great. Yeah, dictionaries, because they're named values. We want name, and then its value should be something, right? We want email, and its value should be something. Cohort value should be something. And we can later on retrieve any of these data using these names themselves if we're using dictionaries. Awesome. This was great, actually. This was great. Okay, so number two, I think tuple inside a list is an okay. This is okay like this. Number two. Oh yeah, thanks Albert for uh, flagging that. For number two, a GPS coordinate, right? Yeah, you're right if the question said GPS coordinates, multiple coordinates, but for a single coordinate, you would use a tuple. But if it's multiple, you're correct. If you have multiple coordinates, then you would store them in a list, right? But not the coordinate themselves. The coordinates will be nested as tuples inside of that list, just as you said it right there. Thanks for flagging that out. Awesome. Okay. Now let's move on to the actual session. Before we get into like all the data structures though, we will have um, like something that we first need to do, which is retrieving data. So the data set that we're going to be working on is every earthquake in the United States Geological Survey that has been detected for the last 24 hours. This can be found in by going to this endpoint. You just copy this one. Actually, I'm just copy it this way. And if you click enter, it would try to download it in your system. However, you can go to like, I think this website only, and yeah, you can retrieve data from here, right? So it's really great. They make it available for you to download data. It's actually a 24-hour data, which is it's the latest data for today, right? So that's what you can actually pull in. So that's what we will be downloading first. And then we will push it into our local SQLite database. SQLite, just because it makes things easier. It's just one file. We don't have to talk to a database management system set up somewhere. It's quite easy to use just SQLite. So that's why we want to use that. So the idea is we're going to pull that in and do some, data retrieval and try to see like how things are going to work when the data arrives at your Python code, right? So it's going to live in a remote area. In our case, it's just going to be a simple file, but think of it like a SQL database living in a server in the internet. You're calling it's giving you data, and how are you going to store it, or how are you going to be accept that data is important. So that's what we're going to be talking about. So for this, you don't have to know anything about pandas or SQL Alchemy. I mean, maybe SQL Alchemy might know just a little bit about it, but it's very minimal code that we are going to be writing, like to retrieve data using SQL Alchemy as well as pandas. We're not going to use much of pandas. The only reason that we are using pandas here is it makes it much more easier for us to download the CSV itself and then store it into a database. I'll show you how easy that's going to be made. All right, so we are going to be importing pandas. It's just a package. Eugenia, that's right. It's an ORM, or Object Relational Mapper, which basically means a middleman standing between your Python code and the SQL table. And then you use Python language to retrieve data. That's the only thing that you need to know right now, I guess. But if you want to know more, you can definitely go into the documentation of SQL Alchemy and read it. Right. So Pandas is going to help us retrieve the data and store it somewhere. And then we are going to dump that data into our SQL database. So I'm just going to be running these two. These are two variables, as you can see, but they're strings. The first is just a simple URL from which we're going to be pulling the data in. And I have a fallback here just because maybe this endpoint is going to be rate limited somehow. I don't know. It could be, right? Because it's a public endpoint that you're going to be hitting. If I hit it multiple times, I might be flagged on their system, and it might rate limit, which basically means it won't give me the data anymore for the next maybe like 1 hour or 2 hours, sometimes even a day. So that's why I have a fallback CSV here for us to use, okay? So this is kind of like the same data that we might be retrieving from the site itself, time, latitudes and longitudes, the depth, and the magnitude in Richter scale of uh, the earthquake. Actually, no, may not be in Richter scale here. There are different types here, so it doesn't matter, I guess. And there's going to be a place somewhere like this one, place names and types and stuff. There's also, interestingly enough, there's like ice quakes. I didn't know this, which is crazy. They also keep track of explosions, as you can see here. So this is just a simple CSV to fall back into. We're going to be using it if we get rate limited. Hopefully we don't. So let's play this one and define both of these lines. Okay, on the next cell, what we are trying to do is I'm using try except. You may not know what this is yet. Don't worry. What this does is basically if these set of commands did not work, then it would execute this one instead of raising an error, right? That's the idea here. If any exception is raised in the first one, which means error happens in this one, the exception would be it's kind of like an if else block, right? If there's any exceptions here, they will fall back here. So ideally, there will not be exceptions raised in this code itself, right? So that's the idea. But what are we doing here? Well, I'm using pandas to read CSV from this URL. I'm going to say that again. I'm using pandas. It's a package, right? So I'm using that, reading the CSV at this specific endpoint. So I don't have to download it and give the file itself to Python. Pandas is going to handle this for me, so I don't have to worry about it. Well, in that case, we will know that we've gotten the data actually. Well, if we are rate limited because of this, this will raise an error if we are rate limited, in which case the exception block will capture that, and then we will instead use our fallback CSV. It would actually be a bummer if we get rate limited. I don't want to do that, or I don't want to get rate limited. However, it could happen. Okay, so let's run this. Hopefully nothing happens. Awesome. That's great. We were not really limited. So what we pulled in for now, at least, is 287 rows of live data, right? And the first three, you don't have to also understand this one. We're getting the first three rows of the table in our CSV, and this is what we got. So three of them. By the way, this is actually a real data in the world. This is in Alaska, this is in California, this is in Nevada. There have been three recordings, but they're very minor actually. If you see it, the magnitude is not that much. 1.5 over 6, it's not that much, but it's actually considerable. That's the type. We have the time also where it was captured. So yeah, great. We got the data now. All right. Our next step is going to be to put this into a SQL database. But before that, though, yeah, that's actually okay. We can just jump on to storing it in a SQL database. Again, you don't have to understand how this code works, but it doesn't hurt to know about it. So create engine is coming from SQL Alchemy itself. It's an ORM, as Eugene mentioned. We're creating a SQLite database named QuakeDB, and it's going to sit in the same directory that my Jupyter notebook is, because I didn't specify anything here, right? So we're creating an engine. Just as the point of execution of this line, quake.db will be created. All right. That's the idea. And then so df dot to SQL is coming straight from pandas. The response from pandas we got here, right? The downloaded data, that is, right? So that we can convert that into to SQL, You give it an engine. An engine basically means a connection point to a database. In our case, it's just a SQLite file. We give it a name, right? This is the table name, the SQL table name. If it exists, if the Quakes table actually exists in the database in SQLite, then we don't have to error. So we'll say replace it. And the last one is index. You may or may not know this, I'm not sure, but indexing is a way of speeding up lookup of information in a SQL table. If you want to know more, it's basically just a tree. It's a BST or binary search tree that gets generated in a SQLite database itself, where you cut your time logarithmically instead of like linearly. So if you were to access, let's say, the millionth row, maybe you're searching that. Well, in that case, the jump is going to be maybe like instead of million records actually looked up, what would happen is just maybe like do like, I don't know, 20 or 30 lookups because of the data structure. You don't have to go in depth into all of that, but what this says is just we don't need any indexing. So it's only 287 rows that we've captured, so we should be okay, right? Awesome. Now at this point, this would create the database and also put all of the rows into the table in the database. And then we have this context manager. We're going to be using this a lot throughout, right? To execute SQL queries inside of this context manager. So this is actually called context manager. Don't worry about it. What it does is it creates a connection between your Python program and the SQL database. And once you finish executing whatever is inside of this block, when you come out, the idea is that connection gets closed. Okay, that's the whole idea. It's nothing fancy. It may look a little bit weird, but that's what it does. And this line right here, engine.connect, it gives you a connection object. And then what you do is you assign it a variable name. It's basically saying like con equals engine.connect. It's kind of the same, right? We're creating a variable and then we're giving it a value, right? It's the same thing that's happening in this context window, sorry, context manager. But you use as to assign a variable name, and then you have access to this variable name inside of this block. Whenever you come outside, the connection is closed. The reason that we want to do this is because connections to databases from programming languages or from a program is actually very expensive in terms of CPU usage and network bandwidth usage. So, I mean, this is just a best practice. We're doing it in a file. We're not going into the internet right now, but this is a best practice, even in our case, okay? Just to put it into our subconscious mind. Always close an open connection. That's it. Okay. Then we can use the connection object to execute a query, all right? Okay, Lucius. It's actually not, if you want to ask me, just do ask me, okay? I'm here to answer your question. If you feel lost anywhere, please stop me. I'm looking at the chat always. So just ask me a question if you're lost, okay? And I'm also saying that you don't really need to understand all of these things right now. And also, if it's just the first time, it's an expected feeling. I was the same when I was learning these things with you guys. It's just because I know it, but I'm explaining it to you, and it's not difficult for me, I guess. But it took me a while to also understand these things. It's not that, I didn't read this today and, show you guys, it's the same feeling. It's just a matter of time. It's just a matter of time, and the amount of time that you allocate, the number of times you repeat these concepts, and then, after some time you're okay. Don't panic about when you when you think that some things are actually going over your head. Don't panic, okay? What you have to is just come back to it and read it again or hear it again. Try to ask questions. And right now you have AI with you also if you're very confused about these things, right? So just don't worry, okay? Hold on tight. All right. Okay, so what we're doing here is just connecting to the SQL database, and then we're executing SQL queries, okay? By now you should know SQL queries. That should not be any difficult thing, right? So that's what we're doing here inside, okay? Select maybe like count from Quakes, get a scalar value, and then we can read that, okay? Don't worry, display this. So the print statement responded, as you can see, said 287 rows now in the SQLite table, Quakes, SQL Alchemy is talking to your databases now. Okay, that's it, okay? No worries. And if you've noticed, there's a new file that was created, quakes.db, that's just a database. By now, this quakes.db has all 287 rows, all right? Fill that piece, yeah. Just ask me a question. Stop me anywhere you want to. All right, okay. Now that we've gotten all of this out of the way, we can now start going through all of this stuff. So let's begin with, I think, get started with, let me see my notes here. Yeah, until that point, if you have any questions so far, just put it on the chat, okay? Okay, let's execute it and we do, okay, awesome. All right, so let's get started with lists. So let me also look at the Q&A if you have any questions there. Okay. Okay, nothing important there shows. Okay, cool. Okay, so for the lists data structure, right? Let's get started with that. The way you define a list data structure is using just square brackets. We'll demonstrate now. The elements in that data structure are going to be ordered. They're going to show up in the order that they have been inserted into the data structure. Those elements in the list itself, they can be swapped. They're changeable, right? And this is actually what you use most of the time to store multiple data if you want them scoped into one variable, most of the time, right? Okay, a list holds items in the order you put them in. You can index them in position. So indexing here means, for example, if I have a list of, let's say, numbers, 1, 2, 3, 4, 5, right? I just created a list here. Very easy, but it's not only limited to only numbers. You can mix different types here and just say hello and worded. By the way, I can do this as well with double quotes, right? So I can mix them this way, right? It doesn't matter. So I just created elements here, but the ordering is actually going to show as is. So the first element here is the number 1, right? It's going to be indexed. It's going to be indexed starting from the number 0, okay? So the first element, regardless of us saying it's the first, which is 1 basically, but doesn't matter. We have to say index 0. It always starts at index 0. So if I say the index list is going to look like 0, 1, 2, 2, 3, 4. This is going to be into the 2 spaces, 5, and it's going to be 6. So this is how the index is going to look like, right? So this is the index 0. So we have about 7 elements here. So if you notice, the last element is actually 7 minus 1. So the length of our, or the number of elements in our list is going to be 7, but the last index is going to be 7 minus 1. So in a general sense, the last index is going to be n minus 1, always, okay? This is going to be the last index, n minus 1. So n means the number of elements that you have, right? You have to just count them, not the index itself. Don't use the index. The index is just a way of retrieving something from there. It's kind of like the address of, or the position of the element. Instead, the count of the elements inside is going to be denoted by n, and the last index is going to be n minus 1. Just take note of this, okay? We're going to see other stuff also with lists later on, okay? Awesome. So now let's pull in data from our database, okay? So what we're going to do is create a connection with the database, just as we did before here. So since we're going to be using this a lot of times, you'll get to understand like how everything works, okay? So I'm going to use with, so I already have engine, right? So engine is already created so for me. Right here, right? Okay, let's go back. Engine.connect as a connection. Okay. And then I go into the block. Now I can execute code here in the database, that is. So what we want here is 10 of the strongest quakes magnitude in descending. The magnitude should be descending, right? Just to show you guys like what we have currently in our database, it's this one, okay? So we have, these are the columns, these are the rows, right? We have a time, we have a, sorry, we have a time, we have longitudes and latitudes, we have the depth, we have the magnitude, and all of this stuff exists, right? So the place as well. Now, what we want is to retrieve data where from the 287 rows, I want 10 of the strongest quakes with the magnitudes descending, which means the strongest earthquake at first and the 10th strongest at the last. That's what I want. So I'm just going to write the query here. So it's the row that I want here, connection.execute, right? Execute, and inside there, so it's just, parentheses. Inside of the parentheses, I'm going to give it a SQL syntax itself. So the way I do that is you use text first and open up brackets also in that text. And it's in there that I will write my select statements, etc., etc. Now I want to ask you guys what I should put in here, because you should already know by now how to query these things, right? Database queries. So I want the 10 strongest quakes. So what should I write here? Can you help me out? I'm rusty on SQL. I'm not very good at it, so I want your help. Anyone want to try? I know it's going to take some time, so I'll give you maybe like 10 seconds to type it in if you want. List from 0 to 9. Is that a question? I'm not sure. But the idea is to get the first 10 strongest earthquakes. So what that means is, for example, in this table, the quake, okay, so let me give you the idea. So it's going to be, select something here. Select, I guess maybe like everything. Let's use everything, right? From quakes, right? And then you can use the column mag, okay? The name can be mag. And then based on that is what you can do, like maybe like ordering, some kind of ordering using the mag column. Okay. I already started it. It should be this way first, right? And then what else do we need to add more into this SQL query? Because as it stands right now, we just dump every row that we have in that table, all to an A7. I only want 10, and not only I want 10, I want 10 of the strongest. Who has the fastest fingers? Okay, Diana says me. Okay, go ahead then. Let's see it. Fraser says limit 10 ascending. Okay. Okay. Interesting. Uh, who else? Who else? Okay, Albert, select everything from quakes, order by magnitude descending limit 10. Does anybody, or does everyone agree with Albert on this? Do you agree with Albert or do you want to write your own? Jacinta says yes. Okay. All right. Okay. I guess Albert's is going to be awesome. Okay. But let me just fix this one because it's going to be a lot of data that will be dumped to us here. I don't want to use like dump everything. Let's instead dump the place and the magnitude only. And yeah, that's it. The place and the magnitude from quakes, okay, instead of asterisk. I'm not saying you're wrong, Albert. I just want to limit the amount of rows. Sorry, the amount of columns. Quakes, then we order it by the magnitude in a descending order, limited to 10 rows, right? Awesome. Okay, so that's great, but we are going to have to come out here and print it out somehow, right? So let's print that out. So rows, it might work. Let me just play this actually. I see. Okay, there's a problem. I have to say dot fetch all. That was a mistake. Great. All right. Okay, so you'll notice we just got the first 10 of the rows, but only 2 of the columns are returned for each row. And you have the place and the magnitude, right? Place, magnitude, place, magnitude. So the strongest one that has ever been recorded in the 24-hour mark, starting from us downloading the data, which it should be like what, like 20 minutes ago, right? At that time, the highest recorded earthquake was 5.8. It's about like 127 kilometers from, what is this? Hawaii? Oh, no, I don't know. But it's in New Zealand. The last or the 10th strongest is in Alaska, China. So none in Africa, actually, the way I see it. The 10 strongest who are not in Africa. There could be somewhere, I don't know. Yeah, so this is how it gets returned. But take note here, how was the data returned to us? It's interesting, right? How is it returned? Can you see how it returned? What data types do you see here from the return value of the execution of the code? So what do you see? How many data structures do you see? And what are they? Okay, a list of tuples, exactly. It's not dictionaries. NumD, it's not dictionary. So what you see here is a list of tuples, okay? You've got a list, and I've talked about this. Lists have orders, right? They have orders. So the first one, this will never change. Every time you use this, so I can just say always, you're like, okay, let me just delete this one and then create a new cell below here, and just say rows at 0 is always going to be the highest recorded magnitude earthquake, always. So the ordering will not change. One, like unless I delete this value, I can actually delete rows. You're saying like del rows. So this line, if I execute it, all of these 10 rows, list of tuples will be deleted from Python. And to get it back again, I would have to execute this line, right? So unless I do that, in every part of my code, so long as this list exists, the ordering will not change. Okay, that's the idea here. Awesome. Okay, so the types here is a list. Each item is inside is a row, and each row is a tuple. We'll meet those next after lists. So that's what we've got. Now let's move on to basic list operations. Okay, so we're going to extract magnitudes from these lists. Okay, then index and slice and then sort them as well. Okay, so these things are very important to work with the data structure itself, the list data structure, so that you get relevant information that you want. Maybe like, let's say you only want 4.9 from New Zealand, or I guess maybe, or you want to do some custom type of filtering in this list. You can do that also, right? So let's see those. Now, so what I want to do now is extracting only the magnitude parts, right? These are the magnitudes, okay? So I'm going to be hitting the tuples also. That's okay. We'll see how we're going to work with tuples later on. But it's kind of like similar how you would use a list. The only difference is that you cannot actually change it. What you can do is create a copy of these things. Okay, how many of you are familiar with list comprehensions? Have you heard of them before? List comprehensions. So let me type them here. All right, okay, list comprehensions. These are not heard but never used it. Okay, cool. So we'll see um, how we can maybe like make it easier for you guys to understand. It's quite dense for now, but let's just extract the stuff and I'll show you like how it actually works. So what I want to do is just extract the magnitudes only, right, from this list. So what I can do is I can just say mags equals, open up a square bracket like this. And for each row, I would choose 1. And for row in rows, that's what I would say. Now, this is cryptic, I know. Don't worry. You get it over time, not today, okay? You get it over time. Don't worry about it first. But it's kind of like a for loop that we're creating here. Again, you'll learn about these loops later on. I think it's going to be next week, but this is a sneak peek and used in list comprehension, okay? Don't worry. Your mind will make the necessary connections as time goes by, okay? These things will just, piece together in your mind. Just continue learning this stuff as you go, okay? If you don't even like understand what it does today, just be curious about it so that your mind can actually make the proper connections later on when you encounter how you use for loops, okay? So that's how our brain actually works. I think it's a good idea to mention that. Now, what we're doing here is just extracting one thing from the data that we got, which is just the magnitude part, and then putting it into a separate list, okay? Okay, so row at 1. What do you think this signifies? I'm going to be a Socratic tutor now and just asking you, and then ultimately I'll get you to understand what's happening here. Row at 1, what do you think is happening here? So as a hint, I'll give you rows are all of these, like these tuples, right? These are the tuples. And trick your mind for now to think that these tuples are actually just lists. All right, don't worry about it. So what do you think will give me a row at 1 here? Okay, 1 is mag in the row. That's great, yeah. Fraser, that's not accurate. You're considering the first row? No, that's not, because the way we're accessing the elements is using indices, okay? Don't worry about it. It's okay if you don't get it the first time. So we're saying row at 1. We're trying to access something from that row. And I just gave you a concession to just think of these tuples as just lists, okay? Don't worry about it. Think of them as lists. We have two elements, right? One is the place, the second one is the magnitude. And if you remember earlier, I mentioned indexing starts from 0, right? So the first element is 0, the next becomes 1. So in that sense, what do you think I'm trying to access this way? Just pick one row, okay? Not all of them. Just pick one row here. What do you think it is? Second row. No, okay. Second row. Okay, this is quite confusing, you guys. Not the second row, but the second column, okay? Exactly. The second element in the row itself, okay? Not the second row. If you say second row, then that would mean this entire list's second row will be, this is the first row. The second row will be this one, right? Not that way, okay? Don't worry about the rest, okay? This is just, row is something else. Here, okay, the thing that might have confused some of you guys to think that this is actually the second row is because we're using row and rows here, right? There's rows, there's also row. There are two things, okay? Rows is this entire list, right? Rows is the entire list, all of the 10 rows, right? But row means just one of them. From those one of them, we're trying to access which element? The second element, right? Indexing starts from 0, right? I get why you're being confused. I understand why that is, okay? But just to revert back and try to show you how this works. Rows is the entire list, okay? This entire list. Well, so we're trying to access each row from the entire list here. So that's what this list comprehension is actually doing for row in rows, right? For every row in rows, just read it that way. For every row in the rows list, we're trying to access something for every row, which means every row is, this is one row, this is the second row, this is the third row, all the way down. But from each of those rows, what we're trying to access here is row at 1, right? So we're trying to access that. Okay. Now, if you just execute this, you get to see like what we're getting, right? It's extracting all of the last elements of each row, which is at index 1, all right? So just to give you an idea, again, I'll copy this whole thing, put it here, right? And just set it to a value. Let's say val equals this, right? Or I can say first row. First row will be rows at 0, right? The first row in our case is this one, right? So rows at 0 would give me the first row itself. So if I execute this first row, it gives me that first row, right? That's okay. But what I'm trying to access again is, let's say, second column, right? The second column. So columns are like vertical ones, right? The first column is this whole places column. The second column is going to be this whole magnitudes column, right? And then it goes on and on. But in our case, we just extracted two of them, two of the columns for each of those rows, right? And then the second column here, what is it going to be? I'll do first row at what exactly? At 1, right? The second column, or the last column, you can call it. The last column is this one, right? For each one of them, it's a magnitude one. Well, if we now print it out, second column, right? It's 5.8 for the very first row, right? That's how we extracted it. So all of these steps are being automated for us when we're using list comprehensions, okay? So max equals row at 1, not rows, okay? Row at 1 for every row in rows. It's actually a good idea to speak it while you're writing it, but you don't have to worry about these things, at least for the for loops part. Your mind will piece these things together when you learn about them, okay? Great, that's not the should remove. Right. Okay, these are the magnitudes. Okay, that's what we did here, okay? So you're accessing the second column slash element magnitude for each row in all rows. Exactly, that's a good way of putting it. That's what we're doing. All right. Okay, now we've got all of those, right? So all of those magnitudes, mags. If we run this, this is the list itself that we got, right? We extracted it, we have a list. Okay, all of the 10 ones are these ones. How do I extract now this first one? How do you think I can extract it? I want to print it out, just the number itself, not the list. What should I say? Anybody? What I want is here, give me some mags. Let me just extract the first element in mags list. What should I do here? Right here. Okay, Lucius says print mags. Print mags would print the entire list, okay? Yes, correct. Eugene, Vundo. So what you do is you print out mags at index 0. That's what you do. So if you run this, 5.8 will be returned, right? Awesome. Okay, so how do I get now the last index value? Extract the last element in mags list. What should I do now? The last element. Just to remind you guys, the last element means the 10th element, okay? Well, not in this case, but like the 10th element, like in the extracted list of magnitudes. So the idea is to extract the last element in mags list. Albert says length of mags -1. Okay, that's a very good way of putting it, but that would just give me a number, right? Or an index value. So I then use that index value somewhere. It's a good idea to do that, okay, Albert? Try to rewrite that. Length of mags -1. That's just an index value you just gave me. Now use that to extract the actual element. Shahid says mags -1. That's the correct way of putting it. That's great. Mags -1, mags at 1. Lucius, that's not correct. Mags at, it has to be -1, or you can use the last element, which is 9, right? Just as Maurice said. And I'm not sure, Eugene, you're correct. You're slicing it there. I just need the last element, okay? I don't want the, yeah, exactly. So I can do two things. What I can do is I can print mags at -1. This is counterintuitive. Don't worry. So if I run this, the last one is going to be returned, right? I should always have, by the way, mags itself printed somewhere, just to make a contrast. And so, yeah, so let me just say comma, first element, and this one, last element. Right? So first element, 5.8, 4.7, so on and so forth. So always last element has to get minus attached. Not always, but it makes sense. Maybe not make sense when you get used to the language itself. If you want to access the last element, you would always go for like a -1 because you know that how you can access it. But like the more robust way of doing it would be how Albert mentioned it here on the chat, which I'll demonstrate here. For example, print mags at. Well, Albert didn't actually finish the answer. This is just part of the answer. Mags at the length of mags -1, okay? This part is the index itself. Length of mags means it gives you the number of elements stored in that list itself, okay? So in our case, this will return 10, right? 10 magnitudes. Why we're using -1 is what I just mentioned like 10 minutes or 20 minutes ago. I don't know where that was. But why we're using -1 is because indices start from 0 and end at n-1, right? That's why we're using -1 here. So this way of writing it is actually portable. If you're using Python, you should be okay by using -1 always. But if you're going to be switching to a different language, -1 is not going to work. -1 to access the last element is unique to Python only, okay? Just take note of that. This is the second way you can access it. The third way is print mags at, you can give it the actual number itself if you know it, okay? Which is in our case 9. 9 is the last index, which is 10 minus 1, right? You would use this one if you know the number of elements in your data set. You would use this one, which is length of mags -1. If you don't know prior to writing this code the number of elements that you have. If you don't know them, this would calculate it for you for every number of elements. The same goes, by the way, for this first one, which is using -1. It doesn't matter. It will always default to the last element, whether you have 10 or 100 or 1,000 lists, right? Great. Okay. So the next one is going to be so what if you don't know the index of the last element? I think I just answered that question, Eugene, right? Lucy says, do we always have to put the int values in brackets? Do we always have to put the int values in the bracket? I'm not sure if I understand it. If you mean that actual numbers here, not always, right? If that's your question. Do I have to use actual numbers here? Not always. You can use actually variables if you want to sometimes, an index variable. You'll get to know these things later on when you begin writing for loops, while loops, when you begin writing functions, you'll understand that you will have to use not exact numbers like these sometimes, but variables, right? I can show you something here using, let's say, a for loop. You don't have to understand it right now, but for, let's say, element or magnitude in mags, you can print out mags at, no, actually, this should be range of length of mags, and this will be the index that you get here, right? And then you'd use the IDX here to print every element one line at a time downward. So if we execute this line, as you can see, it started from, let's actually move these two and we run this. So you'd start with 5.8, 5.8, 5.7, all the way to 4.7. That's how you'd use it. But in this case, as you can see, we just used a variable instead of a number itself, right? So not always you have to use numbers as indices. Sometimes you have to use variables. Don't worry about this though. All right, the next thing I want to do is extract a list from a list. That's what we're going to see. Okay, so what I have to do here is extract the top three magnitudes from the list. So in our case, I can give you an example. The top three are 5.8, 5.8, and 5.7, right? So what I want is 5.8, 5.8, and 5.7 to be returned for me after I write some code here. So what do you think we should use? So this comes to the slicing methodology. So slicing means extracting a certain part of the list using a special type of syntax. Okay, that's what we're gonna do. I'm gonna show you how we can do it. Maybe, yeah. Let me show you this one actually. How to do this one exactly, and I'll ask you a question later on. How we can extract maybe in the middle or somewhere else. So how do we extract this? Then I'll use print mags always, but I do something in this square bracket here inside. Give me a sec. Okay, so what do we do here? I will use, since I said the first three, I'll use a colon sign and then say 3. Okay, don't worry. This might be a little bit confusing. Now I'll show you what's happening here. Oh, sorry. Yeah. Okay. So what's happening here is, well, this is it's actually a little bit advanced slicing, but what I'm saying here is basically starting from 0. Let's just say 0, okay? So what this means is mags at, I'm saying A column B means extracting from index A, okay? I'm going to start from index A, included. This is included to B excluded, right? Right? So the way you denote this mathematically is going to be starting from A like this, and then ending at B like this, okay? So this, if for those of you who remember your math classes, you should maybe like recall this thing. Square brackets means including the A index, and the B index is going to be excluded itself, which means B minus 1 will be the last element, okay? So in our case here, we're extracting the top 3 magnitudes, right? So starting from 0 all the way up to 3, but 3 will not be included. But that's okay, because starting from 0, if you count starting from 0, you have to end at the index 2 included to have 3 elements, right? So it will be 0, 1, and then 2. You have 3 of them. But if you say 3 here, since it's not going to be included, that's just not going to be used in the list that gets returned, okay? So let's see the output. So as you can see, we started from index 0, right? Index 1 was returned, and also index 2, but index 3, which is the 4th element, is not returned, right? So it's not included here. All right, I just showed you like how to get started, right? The starting point is going to be included. The ending point is not going to be included. So I can do a shorthand of this. If it's 0, I can just remove the 0, okay? If it's starting from the beginning, that is, okay? It's the same thing goes for if you want to end at the last element, okay? You don't have to say maybe like -1 like this. You could say it. However, you can just leave it as well. So that would go from index 3 all the way up to the last element, and that will be returned, okay? So let's see if we can get the last element also. This is like this. So extracting from index, let's just remove this one, just to make it easier for you guys to see. And here I'll do extract the um, bottom three magnitudes, right? So for this one, we can do print mags at 3. No, not 3 actually. We can do we can count this, right? So we have 0, 1, 2, 3, 4, 5, 6. We can start with 7, right? Index 7. That will be included because it's the first one, as you can see here, right? And then we end at, I guess, maybe like at the end, right? So the end, you can actually omit it, or you can say -1, yes. Let's omit that and run this one. So we get 4.8, 4.8, 4.7, right? -1 should also work. Okay. -1 didn't work. Interesting. Why did this happen though? Why do you think this happened? I think it should be clear, right? From the definition I just gave you guys. Anybody want to try? Why did this happen? I mean, when I use just, like colon and left the rest to the program itself, it actually gave me all 3 last elements. However, when I said -1, well, it removed the last element. Why is that? Exactly, Albert. That's the correct reason, right? -1 is taking the place of B right here. But we just said B is going to be excluded if it's explicitly mentioned, right? Which is this parentheses, as you can see, the normal parentheses. That's the reason, all right? That's not included. Okay, cool. Now, can we get maybe like, I want to get the first, sorry, I want to get the second, the third, and the fourth elements, right? So let me just write that for you. Extract, second, third, and fourth elements using slicing. So what should I write for this particular case? This one. Okay. We need the second, the third, and the fourth. Exactly. Albert got it. What you do is just you use print magnitudes starting from index 2. Okay. Did Albert get it though? He said 5. Take note of this part. Extract the second, the third, and the fourth elements. Albert said this should do the trick. But will it work though? I mean, it would extract 3 elements, of course. However, are they the second, the third, and the fourth, or are they the third, the fourth, and the fifth? Okay, Albert, Lucius, and Maurice responded, but I've not found, Pascal also responded, I've not found a correct one yet. Anybody else want to try? Or you can correct yourselves if you want. Notice the wording, okay? We need the second, the third, and the fourth elements. That's what I want. You got the slicing correct, but the numbering is not correct. Marie says 1 to 4. No, it's not correct. Okay, I'm gonna show you. So the second element means at index 1, right? Oh wait, sorry, I might have somebody who got it right. Maybe Pascal, right? So the second element means index 1, right? And then the fourth element means uh, index, so the fourth element, right? So index one, so 1, 2, 3, 4, right? This is the fourth element, but its index is 0, 1, 2, 3, right? 0, 1, 2, 3. But I cannot say 3 here. I have to say 4 because if I say 3, it would not be included. So I have to say 4 here. So whoever said 1 to 4 got it right. I think it's Maurice. Yeah, exactly. 1 to 4. Okay. Awesome. So the second, the third, and the fourth one are going to be responded. So if I run this, 5.8, 5.7, 5.3. Okay. Awesome. I mean, I think we can move on. Slicing is, I guess, okay with you guys. Yeah, just understand that sometimes you can omit these elements, in which case it will go all the way to the end. But if you explicitly mention them, they might be included or not included, okay? So that's the idea. Great. Okay, let's move on. All right, so this is, do you guys have any questions? I think Diane, you have a question. Diana, you want to unmute yourself, or should I maybe allow you to do so? Let me see. Is that a question? No. Okay, I guess maybe not. Let's just move on, okay? We may not have enough time to go through everything. Okay, so there's one aha moment that I wanted to show you guys. Okay, so I want you to predict in the chat what does A print in this case. So this is a different thing, not accessing stuff or something like that. This is just assignment stuff, okay? Assignment of um, um, a list to another variable or something like that, okay? So the setup is the following. I have a list, 1, 2, 3. A equals 1, 2, 3, right? Now on the next line, I just defined it, right? That's okay. But on the next line, I have B equals A, right? So what does A print now? What if I say like print A? Sorry, before that, what if I did like B dot append 99, right? And then later on, I try to print out maybe like A, and also print B. What do you think is going to happen in such cases? Who can guess what's going to happen in these cases? Right. So, okay. One thing that to show you guys like what maybe like we missed this one. Append here, what it does is what basically, for example, if B was I don't know, equal to 1, 2, 3, and then I do B dot append 4, then that would result in 1, 2, 3, and 4. Okay, it's just like adding one element at the last element. Appendtion means adding an element at the end. Okay, that's what it means. So now we have A equals 1, 2, 3. Now we just created B here and assigned the value of A in. We appended a value to B. Now, what do you think A will print here, and what do you think B will print? Okay, so Albert says A is going to be equal to 1, 2, 3. B will be 1, 2, 3, 99. Fraser says 1, 2, 3, 99. I'm not sure if that's for both of them. Fraser, do you mean like for A and B? I'm not sure. Eugene says B will insert 99 at the end of the list, but how about A though, Eugene? I want for both of them. When do you I don't understand what Lucius means there. It will add to the list for B only. Fraser says, okay, for B only. As A equal to B will print the same. I think you can, if you want to cheat, by the way, You can do it on your own system and try to see what the output is going to be, by the way. You should probably code it on your system and tell me what you see there. Albert says, because A was assigned to B and the 99 was appended to the B, not the A. Okay. But okay, you might be surprised what you see with like if you actually run it. Okay, let me show you what happens here. Okay. So did you see what happened here? Right? It's crazy, right? It's confusing. I know because I was also confused the first time I learned about this. But luckily for me, I started, well, not, I wouldn't say lucky me actually. It was quite difficult. I started with C first. I learned the C programming language because of ALX. And then I moved on to Python, but it didn't actually take me a lot of time to understand why this was happening, okay? But it was confusing even. Okay, so when we wrote here at this line, B equal to A, you might have thought that we were copying the value of A to B, right? That was what you were thinking first, but that was not what was happening, okay? So what you did there was you basically like stuck a secondary sticker to the same list. The first sticker was A, the second one now became B, right? But it's the same list, okay? This is not the case for other types of like primitive data types like numbers, maybe sometimes strings, I'm not sure though. But it's not the same for numbers as it is for lists, okay? So this worked only here. Now what you did was you have a list already, 1, 2, 3. It already had a label called A, and now you just added a label called B to the same list, okay? So what you're doing right now is you're referencing the same list using two types of names, A and B, right? That's what happened here. That's the reason. Does that make sense? I hope that makes sense. In which case, if you say b dot append, what you're referring to when you say b here is not the copied value. There's no such thing as copied value here. It's actually a, or the actual list itself, right? Think of like there's a list already, and there are a and b having like the same IDs to them, right? So I'll show you what the ID is. Like for example, I can say ID of A. I think maybe this may not work, but don't quote me. So ID of A, right? And I can just say ID of B here. You don't have to understand what ID means, by the way. Oh, okay, I have to print it over. Print ID of A and print ID of B. This. Okay. Did you notice what happened here? ID is kind of like an address, okay? The address of A and the address of B. Now, these two lines should make it apparent for you what's happening, right? Just the same thing I just mentioned, right? There's a list already at this particular address in your memory, and both A and B are referring to it. So if you're using A and B, it doesn't matter. You're referencing the same list. And if you do any kind of operation on either of them, you would be manipulating the data inside of the existing list. So there's not going to be like two copies of the same list. There's only one list with two labels. I hope that makes sense. Okay. Don't worry about this. Okay, let's move on to the next aha moment. So predicting chat here in this setup here, we have x equals 1, 2, 3, and y equals 1, 2, 3 as well. All right. Now, what if I used, for example, here? Actually, let's run this one and execute code here. X is equal to y. What do you think the response is going to be here? What we are expecting from here, by the way, is either true or false, okay? Not actually like a list or something. Okay, Albert says true, true, true. Everybody's saying true. Okay, expected output is true, right? Okay, prepare to be amazed then. Okay, that's good. Most of you got that right. Okay. How about if I used x is y? What do you think this is going to respond to? Is it true or false? This really ties back to what I just mentioned earlier about the IDs, okay? True? You think it's going to be true or false? Okay, we don't have to waste a lot of time. Okay, let's actually print these outputs instead. So, okay, true and false, okay? The first one is an equality, equality operator. The second one is an identity operator. These are two things, okay? You need to know about these things because they're a little bit like confusing for some. Okay, equal in value and equal in identity are two different things, okay? So equal, it asks, are these two things the same content? Do they have the same content, right? Is that true? Yes, right? They have the same content, 1, 2, 3, 1, 2, 3. That's the same, right? Now, when we use is, it asks, are these two things literally the same object in memory? Okay. So most of the time, you want to use like an equal sign actually, most of the time, just to see like the equality of two lists, because it's going to be very confusing if you use is. Okay. Um, just see this. Okay. So most of the time you are going to be or should use an equal sign like this to compare the values themselves. Because if you use is, what it tries to check to see like is the value of the ID of the list labeled as X, as well as the ID of the list labeled as Y. Both of them are two different things, in which case you get a different value. Okay, so I can just sort of show you that. Print ID of X and the ID of Y, right? As you notice, the is value is actually trying to see if both of the IDs are the same, which basically means the same area in your memory that is storing your data or your list, right? These two lists, even though they have the same values inside of them, they're living in separate places in your memory. So you wouldn't get to, you wouldn't say they are actually identical, but they're actually the same content, okay? Great. Not waste a lot of time here. The third one is going to be okay, I think let's move on to the third one, which is using SQL. Okay, so SQL order by only mattered because the result was a list. So let's predict in chat again. When SQL Alchemy, well, we retrieve data from the database, that is, hands me query results, what type does Python wrap them in? What do you guys think this is going to be the answer for this one? What type do you think we're going to get? So first off, let's actually write the code. So with imaging dot as con, it's an ordered list that I get from the connection dot execute text, and I'll say select the place just as we did before, place and magnitude from quakes. order by mag in a descending order, and then limit the first, let's say that the first 5 actually here, right? Let's run this query. We just captured ordered, right? So now if we print out the type of ordered, what should we see here? A list, right? Okay. Okay, I need to finish this on .fetch. All right. The type of ordered is actually a list, right? Now, if I print out the ordered at 0, or the type of the order at 0, so type of ordered at 0, we get an engine like this. All right, let's just print this out first. Now the type itself, let's see. Yeah, it's going to be, it's going to be the strongest. This is what we got, right? So, and if we do the same thing for, let's say the last element, which is the -1, this is going to be the 5th strongest. Okay. So these two look like tuples, right? So the first one is going to be a list, and that's why ordered by is meaningful, because we're using a list, right? To capture it. If SQL handed us back some kind of a set, the first element would be undefined, because sets have no concept of first, right? So the reason ranking, ordering, and top n queries are even possible is that the result lands in a container that preserves the order itself. Okay, when we capture it from the response of the SQL query, we're capturing it in a data structure that takes seriously the ordering of the elements inside. Okay, so when you ask like SQL for limit of 1, for example, to get the biggest something, so you're really skipping, let's say, put it in a list, sort it, hand me index as 0. Python is just doing the same thing most explicitly, okay? Okay. All right, with that, I think we can have like a brief overview of looking at tuples themselves, okay? I hope everything is clear. And by the way, I will be sharing all of this data. I'll fill it. So most of these may not be filled for today's session, right? So I'll just like fill the code itself here so that you can execute it on your side also to see it. You can make a copy. So I'll have two of them, two versions of this. One with stripped down, like no code inside, besides like what we use to create the engine itself and to fetch the data, all that stuff will be there, but everything else, like these live demo parts, are going to be empty for you. And another one, the same copy will have the entire code so that you can reference them by opening up in your Jupyter notebook, okay? So I'll be sharing those later on. All right, so coming to tuples. So tuples look like lists with kind of like round brackets, right? They use the same indexing, same slicing, and the same length accessing methods or length calculation methods. Length means basically just a simple, the size of the tuple itself. So in most cases, it's actually similar to lists. The difference is only one word, which is they're immutable. Okay, they're immutable always, which basically means you cannot change a tuple after you've made it. After you've created the element, you cannot change what's inside of it. So this sounds like kind of like a downside, but it's actually a very good feature. By the end of this section, you get to like see it's actually the opposite. It's not actually the downside. And that's what unlocks tuples to do things that lists cannot do. Okay. Okay. Let's use tuples here. So I'll just connect and capture, for example, here, grab one row from the database and look at its type. Okay. That's what we're going to do. I'm going to do with, I think it's engine, right? Engine.connect as a connection. And inside I will do I'll just capture one row. That will be con.execute text this and inside okay, fetch one. I'll just be like fetching one. But what I want from here is going to be just one row, right? So let's capture the very first one. That's okay. So select, it doesn't matter the ordering. I'll just capture the first one. So place and the magnitude from quakes. Do I need yeah, let's capture everything actually. Not everything, just maybe like the latitude and longitude as well. From quakes, I'll limit that to one. Limiting it to one means just one row would be returned. What I will fetch here actually is fetch one, right? Okay. Now, if I print out the one row after the fetch, this is what I get, right? If I see the type of this, type of one row, it's a SQL Alchemy class with engine row it says, but row itself is of type tuple, okay? Okay, so this, don't worry about this. It may not say actually tuple here, but if it says SQL Alchemy.engine.row.capital letter row, this basically is inheriting from the tuple. It's just, enhancing it a little bit, enhancing the type tuple just ever so slightly, but just consider this as a tuple, okay? Okay, then you can do whatever you want here as you would in a list, because earlier I showed you how you can access or how you can extract a magnitude out of a tuple, right? Just the same way you would from a list. So you can capture the magnitude from here, which is one row at, so the magnitude is 0, 1. It's at 1. So, right? So this is 0 index until all of this. That's the first element. First index, 1 index. So that's the magnitude. So that way, magnitude is 1.8. So tuple support indexing and slicing just like lists. The natural way to make a tuple is round brackets. Okay, I can just create a simple tuple here. X equals 1, 2, 3, 4, and 5. Okay, but it has to be normal brackets instead of square brackets. This is your tuple, right? Yeah, commas are obviously a way to separate them. If you just like have only one element, you should have like a comma just next to it, okay? So if you just want to create an element or a tuple with one, you shouldn't say this way. Type of X is just going to be int, as you can see, right? So you have to use square brackets like this, but if you only have like one element, well, this just becomes an integer, right? It's not a tuple, right? So the way you solve this is by adding a comma just next to the one element. And at this moment, your element just, or your variable just became a tuple, okay? That's how you would create this. And yeah, a very good one of like using like tuples to unpack basically means extracting data out of the tuple, because you cannot mutate it once it's created. So if you want to work on the value that you get from a tuple, then you need to create some kind of a mutable variable somewhere to be able to like work with them, right? Because it's immutable. So how do you extract it? Well, it's quite easy actually. Our row here, as you can see, we have the place, the magnitude, the latitude, and the longitude extracted, right? I can put each one of these elements into their own variables with the following line, which is, I can just say place, comma, magnitude, comma, the latitude, comma, the longitude, then set all of these values to the one row tuple, okay? Like at this moment, each one of these variables capture the primitive data types, in this case, the string, or string is not a primitive data type, but I'm just saying, the floating point numbers, all these will be captured in their own respective variables, okay? So if I were to maybe like print place, print mag, print lat, print longitude, if you want each one of them, they've just been captured. Now I can do whatever I want with them. Instead of just manipulating this one, I can work with these systems. Okay, I think we only have about like 5 minutes. Let's try to, I don't want to rush through it. Yeah, you can maybe like, yeah, I think you can go through the rest of things. I'll just use maybe like this time to maybe show you like the first aha moment, I guess. Okay, so I want you guys to help me out here. So I have a coordinate here, right? Latitudes and longitudes for a place called San Francisco. The original is coordinate, right? So what error do you think we're gonna get, right? What error fires when you try to execute this line of code? So I'm gonna write that line of code saying, so we have a coordinate, right? So coord equals, or sorry, coord at 0. In this case, that's the latitude value. I want to set that to 0. What do you think is going to happen? Okay, everybody is, I guess, tired. Okay. So this will raise a type error because I cannot mutate anything. Okay, it's not actually a value error, it's a type error. Okay, I cannot mutate values inside of a tuple. That's what I'm getting. So that's what we mean by immutability. Okay, you cannot mutate once the tuple has been created. You can delete it if you want by using delete coord like this, which means entirely um, the variable is going to be deleted altogether, right? But you cannot mutate its value, okay, like this. If that makes sense. So the rest of the stuff, so I think we're only left with some aha moments here. And there's sets and there's dictionaries. Sets and dictionaries are very similar, especially in terms of the way they retrieve data from their store. It's very, very fast when you retrieve data from a set or a dictionary, very fast. And there are use cases why you'd want to use maybe like only sets or switch on to using dictionaries. Most of the time, people use sets to save memory area because for dictionaries, you would have to use some key storage area, like a separate key storage area. For dictionaries, there are also some some things that are a little bit complex. For example, for a key, you can actually use a different data structure, like a tuple. A tuple can be used as a key in a dictionary, which is quite interesting because it's an immutable value, right? You cannot mutate a tuple. It can actually be used as a key because it doesn't change. Then it's actually, it's a it can actually be used. It's good enough to be used as a key for a dictionary because of its immutability trait, right? So all of these things, you can find them here. I'll be sharing them. I also have an exercise here for you guys to work on. there are some questions here which you will have to like add the codes here. There's no way of evaluating yourself. You just have to like scroll down and see the answers later on. Right? These are the solutions for each one of them. This includes all four of the data structures, okay? This exercise. It's just a starting point. We'll be sharing more data about this. Go on to YouTube, go on to ChatGPT or your preferred LLM. Then ask it to quiz you if you want to understand these things a little bit more deeper. Don't use them to work on your coding challenges and stuff, but you can ask it to give you like some kind of a quiz, like a 10 question quiz, and then it can grade you and stuff like that. So be smart on using AI, but also YouTube has lots of videos about this. It might be hard to follow everything because going through like a YouTube video is actually much more hard because it takes a lot of time. It's better if you read about it. It's better if you ask AI because it cuts a lot of corners when you ask an AI because it goes directly into the concept itself. It's great. But yeah, just use it wisely. It's a tool, and also it's going to be a bad thing also if you use it in the wrong way. So for today, I'll just stop right here and finish today's session. If you have any questions, do post them on AnswerBase. The team is going to be able to see it and respond to you. Work on these exercises, all the sessions, session notebooks. I'll be sharing with you later on. There's also a PDF guide, which I'm planning to have a session with you, like kind of like a special class, if I can have that. I'll be talking with the team for it. It's just a way for you to set up virtual environments on your system so that you can download Pandas, SQLite, Jupyter Notebook, not on your host system, but in a virtualized environment that you have full control of, so that you don't have any like issues on your system. It's much more better. I use that for myself. I use PyEnt. So this we could walk through like this PDF, but you can, if you want to read it also without any session me holding, you can do it. I'll be sharing this one also with you later on. Yeah, with that, I'll just yield my time and maybe like give it back to who's here? Halima. Yeah. Thanks, guys. See you next time.
Hi everyone again. I hope you learned one or two things from today's session, and well done on staying till the very end of this session. Let me just share my screen. Okay, let me just share the poll. As always, if you have any questions, you can reach out to the data programs team on EO, and then just drop your message and we'll attend to it. Or you can drop a ticket on Fresh Desk on AnswerBase if it's technical related. So please kindly fill the poll that is on your screen so that we can get your feedback on today's session. Okay, for next steps, the assessments for this week, the one that was released, the content that was released this week is due next Monday, 11th of May, and that's data structures code challenge. It's due next week Monday, so do well to submit the assessment. Also, the squad activation challenge is on. The squad activation challenge. So if you enroll for a particular track or you transit to a particular track, you are not going to be activated unless you submit the first assessment. So for you to be activated, you need to submit the first assessment and that is the data structures code challenge, like I said. And so it's a squad thing. The squads are competing and trying to see which of the squad actually has highest activation rate. So you can just do what to submit your first assessment so that your squad would emerge tops so that you not leave your squad hanging. Also, for today's session, you are going to find the recording to be uploaded very soon on EOB Program Hub space, where you can go back to watch the recording if there's something that you missed. Sorry about that. Okay, yeah. Remember that you are not alone in the community. As always reach out to your peers, reach out to your technical mentors on EOB. Also reach out to your squad mates as well. So, post your wins, your challenges, and the insights that you have. If you have an issue, please don't do a solo movement. Try to lean on your mates, on your squad. If for any issue that you're facing, there's always somebody that has faced the issue and has found a solution to it. So reach out, don't be quiet, don't do this alone. And if you're frustrated, it's okay to take a break, but don't give up. Reach out to people, ask questions, and lean on your squad mates. So that will be all for this week. Happy learning, guys, and we'll see you next week next week's PPL.
Minute of love, minute of hate, making mistakes, shying away. I would have held you closer if I could. You bitter than I could ever taste. Now I'm in love and I'm effing wasted. I would have held you closer if I could. And even when we try to throw this all behind, I find myself inside of your arms again. And what if I'm insane and taking me for granted? I would never come to forgive myself. 'Cause I ain't tryna be your ex, so don't call me if you wait. Tryna vibe on my way, I'm on top of my game. I'm on my way, yeah. So don't call me if you wait. Tryna vibe on my way, on top of my game. See you wasting a chance in the corner, like you don't know I'm down to be on. Yeah, I keep on reminding you that you're mine. You're gonna wife me, and I hanging in the backseat, and I waiting for a chance to say bye. 'Cause we've been waiting for love that is real. And even when we try to throw this all behind, I find myself inside of your arms again. What if I'm insane and taking me for granted? I would never come to forgive myself. 'Cause I ain't tryna be your ex, so don't call me if you wait. Tryna vibe on my way, I'm on top of my game. I'm on my way, yeah. So don't call me if you wait. Tryna vibe on my way, on top of my game. Hanging in the backseat, hanging in the backseat. I'm on my way, I'm on my way, I'm on my way there. And even when we try to throw this all behind, I find myself inside of your arms again. And what if I'm insane and taking me for granted? I would never come to forgive myself. 'Cause I ain't tryna be